this be Q. So we have to prove that this perpendicular QP passes through the center. This is the center of the circle O. So we have to prove that the perpendicular drawn at the point of contact passes through the center of the circle. So what is given? You will write, given that there is a circle with center O and AB is the tangent at point of contact P. Okay, and it is also given that QP is perpendicular to the tangent AB. What we have to prove? We have to prove that QP passes through O, that is through the center. So how you will prove this? It is very simple. Proof is, first of all, it is given that QP is perpendicular to AB. Therefore, you can say this angle is 90 degree. Okay, angle QPB is 90 degree because it is given that QP is perpendicular to AB. So you will write the reason given. Now you know that radius is always perpendicular to the tangent because you did a theorem based on this. So you will construct, or you can say join OP. Okay, you will join OP. Now if you will join OP, then you know OP is the radius, and therefore angle OPB will be 90 degree because radius is perpendicular to tangent. This is the reason. Okay, now if this angle is 90 degree and this angle is also 90 degree, so you can say angle QPB is equal to angle OPB is equal to 90 degree. Therefore angle QPB plus angle OPB is equal to 180 degree. This means if the sum of the angles is 180 degree, it means OPQ is collinear. Therefore OPQ is collinear, and hence we will say therefore QP passes through the center. What is the meaning of a line being collinear? It means the points O, P and Q lie on the same line. So if O, P and Q lie on the same line, it means the line PQ passes through O, that is the center. So hence we have proved that the line perpendicular at the point of contact passes through the center. This is our proof. Now see the next question. The length of a tangent from point A at a distance 5 cm from the center of the circle is 4 cm. So this is a circle and this is the center O, and there is a point A. It is given that the distance of the point A from the center is 5 cm. So this distance is given to be 5 cm, and the length of a tangent from point A at a distance 5 cm from the center. So length of the tangent. Now if this is the tangent from point A to the circle, then this length, if this be point B, then this length is given to be, BA is given to be 4 cm. What we need to find is, we need to find the radius of the circle. Therefore we need to find BO. So AB is 4 cm, OA is 5 cm, and OB is to be found. So what you will use? You know radius is perpendicular to tangent, therefore you can apply Pythagoras theorem. So you will say that by Pythagoras theorem, hypotenuse is OA. So OA square is equal to OB square plus AB square. Now what is OA? It is 5. So 5 square is equal to OB is 4. 4 square plus, sorry, OB we have to find out. So keep OB as it is. AB is 4. So 4 square. Now keep OB on one side. So OB square is equal to 5 square, that is 25, minus 4 square, that is 16. So OB square is equal to 25 minus 16 is 9. So this implies OB is equal to under root of 9, that is 3. So 3 centimeter is the radius of the circle, and this is your answer. Now let us see the next question. Two concentric circles are of radii 5 centimeter and 3 centimeter. Now by concentric circle we mean circles having the same center. So these are the two concentric circles. Let the center of these circles be O. Now they are saying that find the length of the chord of larger circle which touches the smaller circle. We have to find the length of a chord. Chord is this is the chord of the larger circle. They are saying that this is the chord of the larger circle, and it also touches the smaller circle at one point. So in this figure I have not made it properly, but you should understand that this chord of the larger circle touches the smaller circle at only one point. It is given. It touches the smaller circle at only one point. Let this point be P. So this would be the tangent of the smaller circle and chord of the larger circle, and radii of both the circles is given to us. What we have to find is we have to find the length of this chord. Let this chord be AB. So we have to find AB, and we know OP is the radius. We know OP is radius of circle. You also know that AB will be the tangent because AB is intersecting the smaller circle at only one point. So AB is the tangent of the smaller circle. So the radius is always perpendicular to the tangent. This is known to you. So therefore you will say angle OPB is equal to 90 degree because radius is always perpendicular to the tangent. So this is the reason. So therefore this angle would be 90 degree. Okay. Now what you will do, you know the result that a perpendicular from the center of the circle bisects the chord. Okay. So consider the larger circle. So this is perpendicular OP on the chord AB of the larger circle. So perpendicular from the center on the chord bisects the chord. This is the result. So therefore you will say AP is equal to BP, because earlier you have proved that OP is perpendicular because OP is the radius and AB is the tangent to the smaller circle. Therefore OP will be perpendicular to AB. Now if this is perpendicular, then this is a line from the center of the circle and it is perpendicular to the chord AB. Therefore it will bisect the chord. Therefore AP is equal to BP, because perpendicular from center bisects the chord. Or you can do it in a different way as well. You can join OA and you can join OB, and you can prove a triangle AOP and triangle BOP congruent. If they will be congruent, then you can prove that AP will be equal to BP by CPCT. You can prove these two triangles congruent very easily. OP is equal to OP common. This angle is equal to this angle 90 degree, and OA is equal to OB radii. So you will prove these two triangles congruent by RHS, and then by CPCT you can say AP is equal to BP. Or simply you can use the result that a perpendicular drawn from the center of the circle to the chord bisects the chord. So you can use any of the two ways. Both of them are correct. So I am using this one. AP is equal, therefore AP is equal to BP. Now it is easy to find one BP, one part of this AB means BP or AP. You can find out. Consider triangle BOP. So in this triangle you will apply Pythagoras theorem, because you know OB is the radius of the larger circle and it is given to be 5 centimeter, and OP is the radius of the smaller circle and it is given to be 3 centimeters. So you can find PB. Okay, so in triangle BOP, by Pythagoras theorem, what you will say that hypotenuse square, that is OB square, is equal to OP square plus BP square. Now put the values. OB is 5, so 5 square is equal to OP, that is 3 square, plus BP, that you have to find out. So BP square is equal to 5 square, that is 25, minus 3 square, that is 9. This is equal to 16. So from here you get BP square is equal to under root 16, that is equal to 4 centimeter. So 4 centimeter is the length of BP. What you have to find is, you have to find the length of the chord. So chord is AB, which is equal to AP plus BP, and you know BP is equal to AP, so you can write AP as BP only, plus BP, that is equal to 2 BP, and that is equal to 2 into 4, that is 8 centimeters. So 8 centimeter is your answer. It is the length of the chord. Okay, now see the next question. A quadrilateral ABCD is drawn to circumscribe a circle. So this is a circle and a quadrilateral is drawn to circumscribe this circle. Circumscribe the circle means the circle is inside the quadrilateral, touching the sides of the quadrilateral. We have to prove that AB, that is this side, AB plus CD is equal to AD plus BC. So how you will do this? You see the figure. This is point A and the circle is touching the side AD at one point S, and it is touching the side AB at one point P. Okay, so it means as the point of intersection is only one with the circle, therefore AB is also the tangent, AD is also the tangent, DC is also the tangent, and CB is also the tangent through the circle. So these four are the tangents, and A is an external point outside the circle, and AS and AP both are the tangents to the circle. Now you know the result that lengths of tangents from an external point, you did the theorem, from an external point to the circle are equal. So similarly here also we will use this theorem only. As A is an external point, so AS and AP are two tangents that are drawn to the circle from this external point. Therefore by the theorem we will say that the lengths of these two tangents, that is AS and AP, is equal. So using this theorem you will say that AS is equal to AP. This is equation 1. Similarly you will say D is also an external point. From this point two tangents DR and DS are drawn to the circle. So you will say here also DS is equal to DR, because the length will be equal as they are drawn from the external point D. We are using this theorem only. And similarly C is an external point, so you will say that CQ is equal to CR. Okay, this is the third equation. And similarly B is external point, so you will say BQ is equal to BP. So these are the four equations that you are getting from this theorem. So what you will do is, in order to prove this equation, you will add these four equations. Adding 1, 2, 3 and 4. So what you will get on adding, you will add left hand sides and right hand sides. So AS plus DS plus CQ plus BQ is equal to AP plus DR plus CR plus PB. Now AS plus DS will become AD. So AD plus CQ plus BQ will become BC is equal to AP plus BP. AP plus BP will become AB and DR plus CR will become DC. So you can interchange the sides. You can write it as AB plus CD is equal to AD plus. You have to remember that you have to keep the sides that you need to prove on one side. Means you want AB and CD on one side. So keep these, means this is the part of AP, and BP is the part of AB, and similarly CR and DR are a part of CD. So these two are on left hand side, so keep AS, DS, CQ, BQ on one side and AP, DR, CR, PB on the other side, so that you will get these terms only. Otherwise you can create confusion for yourself. So it is better to keep the terms that you want on one side on that side only. Now let us see the next question. Now in this question, this figure is given to us where this is a circle and xy and x dash y dash are the tangents to the same circle that are parallel to each other. And AB is also tangent to the same circle where the point of contact is C. What we need to prove is, we need to prove angle AOB is equal to 90 degree. So you can see that from this figure that angle AOB is a part of triangle AOB. So if you know these two angles, means angle AOB and angle OAB and angle OBA, then you can find the third angle, because you know sum of all angles of triangle is 180 degree. So in order to use this result, you need to find these two angles. So for that we will do construction. So our construction is to join OC. Okay, so we will join OC, and after joining OC we will use triangles. Now we are proving, we are doing our proof. So we will say in triangle POA and triangle COA. Okay, we will use these two triangles. Now we will say these triangles, we will prove these triangles to be congruent. How? We will say OP is equal to OC radii, therefore they are equal, and OA is equal to OA common, and the third will be PA is equal to CA. You will say, or you can say AP is equal to AC, because the tangents drawn from an external point to circle are equal. This is the theorem that we did. So by this theorem we will say AP is equal to AC. Therefore we can say by SSS triangle POA is congruent to triangle COA. Now if these two triangles are congruent, then we can say that by CPCT angle PAO will be equal to angle CAO. You can say this by CPCT. So you can also say that angle PAC, means this angle, is equal to angle PAO plus angle CAO, means this angle is equal to this angle plus this angle. And as PAO is equal to CAO, so you can say angle PAC is equal to twice of angle CAO. Similarly, you can prove this triangle means triangle OCQ, OCB and triangle OBQ to be congruent, and from there you can say by CPCT that angle QBO will be equal to angle OBC, and therefore you can say similarly. You don't need to prove these two triangles also congruent again. You can write similarly. You can say that angle QBC will also be equal to twice of angle OBC. Okay, so you have these two equations now. Now what you will do is you will add these two equations. So I am writing adding 1 and 2. What you get? You get angle PAC plus angle QBC is equal to twice of angle CAO plus twice of angle OBC. Now from here you can take out 2 common, and in bracket you are left with angle CAO plus angle OBC. And you know that angle PAC means this angle and angle QBC means this angle. These are interior angles. Okay, these two are interior angles on the same side, angle PAC and angle QBC. Therefore sum of interior angles on same side is 180 degree. Therefore you can write it equal to 180 degree. Reason, interior angles. So this is the reason. So you can write PAC plus QBC is equal to 180 degree. Now from here you get angle CAO plus angle OBC is equal to 180 degree upon 2, that is 90 degree. Now if angle, see the figure, if angle CAO plus CBO is 90 degree, means sum of these two angles of this triangle is 90 degree, then this angle you can find out. You will say in triangle AOB, you can see the figure, in triangle AOB means this triangle, angle CAO plus angle OBC plus angle AOB is equal to 180 degree, because sum of angles of triangle is 180 degree. Sum of angles of triangle is 180 degree. So this is the reason. So CAO plus OBC is 90 degree plus AOB is equal to 180 degree. So from here what you get, angle AOB is equal to 90 degree, and that is what you need to prove. So this is hence proved that angle AOB, that is this angle AOB, is 90 degree. So this is the solution of 9th question. This is important question. Now we will do 10th question. Prove that angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact at the center. It means if this is a circle and tangents are drawn from an external point P. So these two tangents are drawn from the external point P. Let this be point B and this be point A. Then they are saying to prove that angle between these two tangents, it means this angle, is supplementary to the angle subtended by the line segment joining the points of contact at the center. So if this is the center, then the angle subtended by these two line segments joining the point of contacts and the center of the circle, it means this angle. So we have to prove that this angle and this angle, they both are supplementary, means sum is 180 degree. So we need to prove that sum of angle AOB and angle APB is 180 degree. This is very simple. You just need to use one result. You will say that radius, OA is radius and AP is tangent. You know radius is perpendicular to the tangent. This is the only result that you will use here. Radius is perpendicular to tangent. Therefore, angle OAP is equal to 90 degree. means this angle is 90 degree because this is the radius and this is the tangent. Similarly, and angle OPB will also be 90 degree. OBP is equal to 90 degree. So this angle is 90 degree and this angle is 90 degree, and this AOBP is a quadrilateral. AOBP is a quadrilateral, you know, it is a quadrilateral. Therefore, you also know that sum of all the angles of quadrilateral is 360 degree. So you will say angle AOB plus angle OBP plus angle BPA plus angle PAO is equal to 360 degrees, because sum of angles of quadrilateral is 360 degree. This is the reason. Now AOB you don't know, keep it as it is, and APB you don't know BPA or APB, it's one and the same thing. Angle BPA you don't know, but you know OBP and PAO, that is 90 degree and 90 degree. So plus 90 degree plus 90 degree is equal to 360 degree. So from here what you get, angle AOB plus angle BPA is equal to 360 minus 180, that is 180 degree. So this is equal to 180 degree. Therefore you have proved, you have to prove this only, that these two angles are complementary, and you have proved so. Complementary is supplementary. You have to prove that these two angles are supplementary, means you have to prove the sum of these two angles to be 180 degree, and that you have proved. So you write hence proved. Now let us see the next question. Prove that a parallelogram circumscribing a circle is a rhombus. So parallelogram circumscribing a circle means a circle is drawn inside the parallelogram, and we have to prove that this parallelogram ABCD is a rhombus. So you know that all the sides of rhombus are equal. So that is what we need to prove. So we will prove the same. How you will do that? First of all, you know that DA, AB, BC and CD all are tangents to this circle with center O. And you will join SO and OP. And what you will do is, you will prove this triangle and this triangle congruent. When you will do so, then you can prove the sides to be equal. See how? So first of all, you will consider triangle SOD and triangle POB. So you will consider these two triangles and you will prove them to be congruent. How? You will say first of all OS is equal to OP, because they are the radius of the circles. Same circle, so same radius. So OS is equal to OP. And what else you can do? You can say OD is equal to OB. OD is equal to OB because the diagonals of parallelogram bisect each other. Diagonals of parallelogram bisect each other. This is the reason. And what else can you do? You will say these are the two triangles. So you can say PO perpendicular to AB and OS perpendicular to AD, because AB is the tangent and PO is the radius. So you know the result. So you can, if these are perpendicular, so you can say that the angle is 90 degree. This angle is 90 degree and this angle is 90 degree. So angle OPB is equal to angle OSD, because both are 90 degree. Why they are 90 degree? Because radius is perpendicular to tangent. This is the result that we have used here. So therefore by RHS, triangle SOD is congruent to triangle POB. Therefore you can say by CPCT you can say that SD is equal to PB. Okay, so you can say SD is equal to PB. Now what you will do, that you know A is an external point and this is a circle, and AS and AP are the tangents to this circle from the external point A. So you know this theorem also, that the tangents from an external point to the circle are equal in length. So you will use that theorem and you will say that AS is equal to AP lengths of, because reason is lengths of tangent from external point are equal. So this was the reason. Now you will name this equation to be 2 and this equation to be 1, and you will add these two equations, add 1 and 2. What you will get? You will get AS plus SD is equal to AP plus PB. So AS plus SD is equal to AD and AP plus PB is equal to AB. So you get AD is equal to AB. So as AD is equal to AD, you have proved. Similarly, you will if you will consider this triangle, and if I will join OQ also, so if you will consider this triangle and this triangle, then also you will be able to get the same result, that AP is equal to BC. And similarly, if you will use the other triangles, you will get BC is equal to CD and you will get CD is equal to AD. So you can write similarly you will get all the sides to be equal, that is AD is equal to AB is equal to BC is equal to DC. Now since all the sides are of the parallelogram are equal, therefore ABCD is a rhombus, hence proved. So we will discuss the remaining questions in the next video, and we will also discuss some extra questions that are asked in the board examinations from this chapter.